As I mentioned, the previous XML features only exist because of new LINQ to XML querying features. In order to support queries over XML, LINQ needed new classes and features. And this section then focuses on LINQ queries. Let's start by creating a very simple query over some XML data using LINQ. I'll choose option I to demonstrate creating a query using LINQ. I'll start by loading up the same XML file we've been working with, and here is the query we're going to look for. We're going to find all the customers in the USA using LINQ to do the work. From cust, which becomes an X element, in customers.descendants, and I'm only looking for descendants at any level whose name is customer. So we'll look for elements at any level beneath the root named customer. Now, we'll filter that list using a where clause, and we'll say, well, let's filter based on cust.element. We're looking at one level beneath the customer for an element named country. We get the value of that element, and it should be the word USA. In that case, we select the entire cust, that is, the X element containing that customer's information, and we get a collection of those, a queryable collection. And we'll now call display companies to display that list of customers in the US, and it is exactly what you'd expect, the same list of customers in the US. Some things to note here, I've used the descendants method, the descendants axis method, given the name of the element I want to look for. This looks at any level beneath the root of this XML for elements named customer. And then we'll filter only looking one level down from each customer for an element named country. We retrieve its value and compare it to USA. So we have used LINQ here with the axis methods we looked at in the previous section to create a list of all the customers in the US. In the previous example, our LINQ query returned all of the XML content. What if you only want a subset of the XML content, maybe a field or an attribute or two? Just as with any other LINQ query, you can create an anonymous type containing a subset of the available data. You supply the structure, and LINQ will supply the values. Let's look at an example that shows off working with an anonymous type and LINQ to XML. I'll choose option J, LINQ Demo 2, and this shows us how to create an anonymous type with the results we need. Here is our LINQ query. We've loaded up our XML content, and this time we'll retrieve the same customers from the USA, so the from and the where clause are the same as in the previous example. The select clause is different, however. We have select new, which indicates we're creating an anonymous type, and then we'll use object initializers to initialize the values in that type. We'll set customer ID, that property, equal to this value. Let's review what we have here. Cust is our current customer. We'll look within it, only one level down, for an attribute whose name is customer ID and retrieve its value. We'll set the company property to be the current customer, look one level down for an element whose name is company and get its value. We'll set the phone property to be, start with our customer, look one level down for an element named phone, and get its value. Now that we've created this anonymous type, we can retrieve the values as properties of each item in our collection. There's a customer ID property, a company property, and a phone property that are there only because we created this anonymous type. If we didn't have this anonymous type, what would be in each element in customers in US? It would be a block of XML. And we'd have to use XML features like item.element something to retrieve information. But since we've created these properties, that's what we project out from this collection. And so we use those properties when retrieving information. And of course, the output is exactly the same. But this time, we used an anonymous type containing 3 properties to get the output, as opposed to up here, we just displayed the customer itself, and display companies, let's go look at that procedure, did the work of breaking out the attribute, the element, and the element itself. So depending on which procedure we call, we display different information. We can either use an anonymous type to create those properties or retrieve them ourselves in code. LINQ provides a large number of query extension methods, and hopefully you've studied some of those. You can perform calculations and conversions on elements or groups of elements using these methods. You'll find methods like all, any, average, where, concat, contains. We've covered those elsewhere in this course. There's convert all, count, distinct, except, we've seen some of those, order by, then by, and select. And there are many more methods provided by the system.LINQ.enumerable class. Our demo uses the any method, which returns true if the collection contains any elements or any elements that meet a specific criterion. Let's try an example using the any method. I'll choose option K to work with LINQ functions. Here we are. And in this case, I load the XML, and now I'd like to use a query to retrieve a list of all the customers that have orders, and I want to find out how many orders each customer has. So here's the trick. We have two from clauses. This is the first time I've used this technique in this course. From C in customers.descendants named customer. So we'll loop through all the customers. And then from O in C.descendants named orders. So we'll look within each customer for any element named orders. We'll let count equal O, that's our orders, dot elements dot count. And this will be on a per customer basis. So far we've used the count method provided by system.LINQ.enumerable class. We'll order by count descending, and we'll only display output where O.elements.any is true, where there are any orders. Now, the tricky part of this is looking at the two from clauses. From C in customers.descendants named customer lets us march through all of the customer elements. The second from clause, from O in C.descendants named orders, lets us march through all the orders for each customer in turn. So we'll do work for each customer before moving on to the next customer. Now, how do we project the data? We'll create an anonymous type containing two properties, company, which contains the company name, and count, which contains the variable we stored away right up here. And now we'll loop through that data, the output from our query, and display the company and the count of orders. And notice up here, we ordered by the count descending. So we're in descending order by the number of orders placed. If we run this full speed, you'll see there were 3 customers that placed an order at all, and we've shown the data in descending order by the number of orders each customer had placed. Take some time to investigate this query. It's somewhat complex, but it shows you the power of using the LINQ.enumerable functions within your LINQ queries. Our last example retrieved information for all customers who had placed any orders using the any method. What if you want all customers who have placed any orders but have used federal shipping as their shipping method? The any function that we looked at can do it, but you have to calculate a subset. And in this case, as you've seen in many other examples in this course, we'll need to use a lambda expression to do the work. Let's look at our example modified to only show us customers that used federal shipping for a particular order. To show off working with lambda expressions, I'll choose option L. Here we are. And everything's the same in this example except for one thing. When we call the any method here, we're not just calling any with no parameters, we're passing a lambda expression. Now, because O is our collection that contains order elements, we know we're going to get an X element that's order information. So I named it order. That's the parameter we'll pass to our lambda expression. We only want to find out if we have any orders where the ship via element's value contains the text federal shipping. So this any method has a lambda expression which acts as a where clause, where order.element named shipvia.value equals federal shipping. If that's not the case, they won't be included in this output. And actually, I misspoke before. All we care about is if any of the orders were shipped using shipvia. So this would be like we want to know, here's all our customers, they've all placed orders. We only care about the customers that have ever placed an order using federal shipping. If they have, we need to send them an email to do something with them or who knows what. In any case, we'll find out from these results, any customer who has placed an order using federal shipping, how many orders that customer has placed. And you'll see that although we received 3 results last time, we only get 2 this time because only these 2 customers have any order placed using federal shipping. You'll find that it's easy to use LINQ features to transform XML. And you're saying, what about my old friend XSLT? Well, certainly for simple operations, XSLT is far too difficult to learn. Entire thick books are written on transforming XML content using XSLT, and I don't like to use it. I like LINQ a lot better. It's the LINQ select clause that can include expressions, and these expressions show how you want to project the data. That is how you want to transform the data as you run the query. You can generate new XML elements with select. You can actually generate any kind of text with your select statement. But we're going to generate new XML elements within the select as the query iterates through its input. Now imagine we're starting with this XML content. I'd like to end up with this XML content. Notice the difference. On the left, we have a customers element with customer elements inside of it. On the right, we have contacts element containing contact elements, and within the contact, we don't have a contact name, we have a name element. We have a company element, that's the same as the previous one. But notice in the original, rather than having phone elements, we have fax and phone. Well, why should fax and phone be different? They're just phone numbers. So on the right-hand side, I would like to transform those into phone elements where an attribute indicates what kind of phone number it is, work or fax, home or mobile, or so on. So our goal then is to iterate through our collection of customers and transform the content from the format on the left to the format on the right. I'll choose option M to begin the transformation, and you'll see here that we start by loading the XML file as before. Now you got to read this carefully. We have a variable named contacts, which contains a new X element named contacts with this as its content. The content is the results of running a query. And the query is from C, which is a variable, which will represent each customer in customers.descendants named customer. So we'll loop through all of the customer elements, that's our input. And then there's a select statement, that's our output. For each customer, we're going to output a new X element named contact. So we have input, we have output. We do this output for each input customer element. If we run this full speed, we end up with an empty contact element for each customer in the original input. Okay, we've got a good start. Let's go to option N and take it a little farther. Here we call the load method again, same as before. This time, we have the same input from C in customers.descendants named customer, but we have different output. We'll select a new X element named contact, but this time we'll supply content for that contact element. We'll have a new element named name, and its content will be a literal value, just this string. So every contact element will contain a child element named name with fixed content. If we run at full speed, you'll see this is what we end up with. Each contact element contains a child element named name, and the fixed content within that child element in a moment we'll replace with variable content for each contact. Well, let's try the third version, option O. Here we start the same, but of course our query gets more complicated. The difference here is the content of the contact element is this. The contact element contains two other elements. There's a new X element named name, and here's the content of that name element. It is, from the original input, the element named contact name, get its value. We also take the original from the input, C represents the input, remember, the original company element, and just copy it over directly from the input to the output. There's no transformation going on there. We're just taking it from C.element named company and placing it into the output. If we run this full speed, you'll see we get within each contact a name element containing the original contact name value and the original company element copied over directly from the input XML. Well, we're almost done because the last step in our transformation just extends that concept a little farther and creates for us not only the name element we've seen and the company element we've seen, but also a new element named phone with an attribute named type with a value of work and content of the original value of the phone element from the original XML. We'll have another new X element named phone containing an attribute whose name is type with the value of fax and containing the value of the original fax value from the input XML. If I run this full speed, you'll see we've done it. We've created a new contact list where every contact contains information from the original customer's XML, but formatted in a different way. We have name and company elements. We have phone elements with an attribute that indicates what kind of phone number it is, containing the original phone number value. So we have completely created our transformation using LINQ to XML. I know it seems like a lot of work here, but it's way easier than learning XSLT, and over time this becomes second nature. It's very exciting how easy it is to create transformations using LINQ to XML.